Swift includes a way to specify with precision if something is a constant or if it can change over time. Constants and variables associate a name with a value. When you define a constant or variable, Swift allocates storage for the value in memory and associates the constant name with the assigned value. Constants are defined using a let keyword. Once you create a constant, you cannot change the value. We see an error here when we try and do that. Variables are defined using the var keyword, and you can assign a new value to the variable after it has been created. This is an example of assigning a constant to a variable and then modifying the variable. We have a constant of default score, which equals 100, and we want to set this default score to each player once the program begins. Now say player 1 scores. Then we want to increment the score to 200 later on, and var allows us to do this. Use a constant when a value won't change during the lifetime of a single execution of code. Now let's say we have an app for calculating distances traveled on a trip. In other words, it tracks one trip per execution of code. So let's go through some scenarios where you would use a constant and where you would use a variable. So let's say we have the starting location. Would this be a constant or a variable? This is a GPS coordinate of where you started your trip. Once you begin tracking a trip in your program, the location won't change. So you'll represent this value with a constant. And then we have destination. Would this be a constant or a variable? The GPS coordinate is where you want to arrive. Your app can be used for many destinations, so you may think that this would be represented with a variable. But once your program begins tracking a trip, the destination won't change. So you want to represent this value with a constant. And then we have current location. Would this be a variable or a constant? The GPS coordinate of your current location will change whenever you move. So we'll represent this value with a variable. How about distance traveled? Do you think this would be a variable or a constant? How far have you traveled from your starting point? This value changes as you move. You'll represent it with another variable. Remaining distance? Do you think variable or a constant? How far must you travel to arrive at your destination? The remaining distance changes as you move. You'll represent this value with a variable. So why should you use constants at all? Well, first, if you set a value to a constant, the compiler understands that it should never be changed. This means you won't be able to build or run your program if you try and change the constant's value. In this way, the compiler enforces safety. Second, there are special optimizations that the compiler can make for constant values. When you use constants for values that won't change, the compiler can make low-level assumptions about how to store the value. These adjustments allow your program to execute faster. Third, it is simply the right way to do things in Swift. There are some rules when naming constants and variables. No math symbols or spaces, and the name cannot begin with a number. Otherwise, you're allowed to use emojis and Unicode to name your variables if you want. You can see some examples of that here. When naming, there are some best practices to keep in mind. So we want to be clear and descriptive. We don't want to name variables N or A or B. We want to name them in a way that is going to be clear what that variable is. We also want to use camel case when multiple words are in a name. So here we see first name is all lowercase, which it should actually be represented as first name camel case. You can also make comments in your code that will be ignored when your code is compiled. Comments are usually used to explain difficult sections of code, provide copyright information at the top of the file, and to provide date information when the file was created and/or modified. Now, this isn't only useful to you, it's useful to other developers who maintain the code base in the future and can be used to write documentation later on. If the comment is on a single line, you can use 2 slashes. If you do have a multi-line comment and you want to use the asterisk and a slash like you see in the slide here. Swift uses type to mean a grouping of properties and functions. We'll see that Swift has fewer differences between classes and non-classes, or structs in this case, than some other languages. Types can have a data and behavior, in other words, properties and methods. Notice some of the keywords here. We have struct, let, and func. We'll definitely cover these as we go through the course. This code sample shows a person type, creating some instances and calling some methods. Again, these things will be described in detail as we go along. Here are some of the most common types you will be creating and using. An integer, or int, represents whole numbers. A double represents numbers requiring decimal points. A boolean, or bool, represents true or false values. A string represents text. There are also arrays and dictionaries that are often used, but we'll cover these in more detail later. Swift is considered a type-safe language. Type-safe languages encourage you to be clear about the types of values you're creating. Here we see Swift's type safety in action. When we try to assign a different type to a variable or constant that has already been declared as a different type. So here we have player score, which is 1,000 and of type int, and we try to assign player name, which is a string, to player score. That's when we see a compiler error that we cannot assign the value of type string to int. Swift can often infer the type. Here, Swift infers that city name is a string and pi is a double. It is okay to put the type if you want to, or sometimes when you need to. This is called type annotation. Next, we'll see some cases where specifying the type is required. The first common case is when you create a constant or variable before assigning it a value. The next common case, when you create a constant or variable that could be inferred as 2 or more different types. So in the first line of code here, if we didn't annotate the type as a character, middle initial would be considered a string. In the second line of code, remaining distance would be inferred as an int if we did not annotate the type as a float. When you're adding other properties to a type definition is the third case you would use type annotation. Here we see an error because the type is not annotated. So we need to assign the type like this. Another example of safety in Swift is you must initialize variables or constants before you use them. X is initialized before it's printed out here, so we're good now. When working with numbers, you may find that you need to assign a very large value to a variable or a constant. This can be difficult to read, since it's hard to see how many zeros are in this ugly number here. Fortunately, Swift allows you to put underscores in your numbers as a way of formatting for easier reading. These underscores are similar to comments in that they are ignored by the compiler. Now you can open and complete the Constants and Variables playground for Lesson 2. Good luck!